Dear students, this is P. Sathiaseelan, Assistant Professor from Department of Chemistry, Bishop Heber College. You are welcome to the second lecture of Module 1, Photodimerisation reaction. Dear students, greetings to all of you. And today, in continuation with the previous lecture, we are going to discuss photodimerisation of diene and the photodimerisation of aromatic system. Let us take photodimerisation of diene. So we can start with conjugated diene. If you irradiate with light in presence of sensitizer, then you can have three different products. Two products are substituted cyclobutane. This is one product, and second product is this one is second product, and third one is vinyl cyclohexane. This is third product. 1, 2 and 3. Now if you look at these three products, which one will be the major product? That will be the question. In previous session, while discussing photodimerisation of alkene, we got two products with equal proportions. But here, based on the nature of sensitizer we are going to take, your product proportion also will differ. Okay. In case 1, product 1 and 2 will be the major product. That is 90% of your product will be product 1 and 2, that is di-substituted cyclobutane, and product 3 will be only 10%. In case 2, product 1 and 2 will be around 40%, but product 3 will get with 60% yield. That is, in case 1, di-substituted cyclobutane will be the major product, and your 6-membered ring, this product will be the minor product. And in case 2, vinyl cyclohexane will be the major product, and di-substituted cyclobutane will be the minor product. Okay, as usual, why? We'll discuss. You see, so I'll erase this one also. Let us discuss the mechanism of the process. Then you can easily understand. Now let us take, so initially when you are going to irradiate your reaction mass, there will be the sensitizer. So of course sensitizer will undergo irradiation. S for sensitizer will undergo excitation. So in presence of photochemical condition, your sensitizer will go to singlet state, initially excited singlet state, and from excited singlet state by intersystem crossing, your sensitizer will attain triplet state. Okay, so here this is nothing but a sensitizer. S stands for sensitizer. Singlet and sensitizer by intersystem crossing will attain triplet state. This is the first step. And in the second step, already we know your triplet state sensitizer will interact with butadiene. So when it interacts with the butadiene, your butadiene will undergo excitation and it will be there in, it will form a biradical. Already we know, already I said, your alkene, if it is then triplet state, it will follow biradical mechanism and biradical formation. So your biradical alkene will be there at triplet state, and sensitizer will come to ground state. Okay, will come to ground state. Now this is S trans form of butadiene. At room temperature, S trans form and S cis form both are possible. This is S cis form of butadiene, and similarly S cis form also S cis form can interact with your triplet state sensitizer. Consequently, your S cis form will form a biradical, that is, it will undergo excitation to give triplet state biradical, and by providing energy, your sensitizer will come to ground state. So this is second stage. In the third stage, this biradical, I mean triplet state biradical, will interact with your another compound butadiene, one more molecule of butadiene. Okay, let us discuss. So I'll erase it. Okay, now here let us take this triplet state transform, triplet state of transform reacts with ground state alkene. So this will be there in triplet state, excited triplet state, this will be there in excited triplet state, and your this will be there in ground state. Okay, so to draw the mechanism, I'll erase it for my convenience. Okay, now this one will go and interact with radical mechanism, here ground state diene. Okay, and another electron will come and sit in this carbon, and it'll get initially it'll get okay. Now here there will be one radical electron, and this is a new bond formation between these two carbon. Okay, now this will interact with this carbon. Since this pi bond having two electrons, one electron will be there here, another electron will be there here, so this will come and interact with this carbon, and this electron will go and form a pi bond with this terminal radical, and you will get two products. Okay, when there will be the bond formation, two different substituted cyclobutane you'll get. Okay, first one is this is transform, one substituent above the plane of the ring, another substituent below the plane of the ring. Okay, and the second product is cis form, both the substituents will be there either below the plane of the ring or above the plane of the ring. So this is the transform, one substituent above the plane, another substituent below the plane. Here both the substituents, either it will be there below the plane of the ring or both are above the plane of the ring. It will be above the plane of the ring. So you'll get two products. Now among these two, which one will be the major product? Okay, so among these two, this one will be the major product and this is the minor product. Okay, around 75% you'll get this product transform, and cis form you'll get only 10 to 15% cis form. So now cis form, let us take this. Cis biradical interacts with the ground state diene. Mechanism will go like this, radical mechanism, and this will go and sit in this carbon. Okay, now new bond formation between these two. This pi bond will be there as such, and here we have one radical, here another radical. These two radicals will form a sigma bond, and finally you'll get vinyl cyclohexene, and this will be the minor product. Okay, in the first case these two overall, these two 90%, and this one only 10% in the first case. Now I'll tell you why this one, according to first case, why this one will be the minor product and these two, I mean disubstituted cyclobutane, will be the major product. Okay, if you consider energy of this triplet state, I mean transform triplet state energy is 58.3 kilocalorie per mole. Okay, and energy of cis is triplet state, cis biradical energy is around 53 kilocalorie, approximately 53 kilocalorie per mole. Already I told you, based on the nature of sensitizer which we are going to take to carry out this reaction, major product will differ. Okay, that is proportion of your product will differ. If you are going to take sensitizer with approximately around 60 kilocalorie per mole, then you will get this as the major product. Okay, so sensitizer with greater than 60 kilocalorie per mole energy, sensitizer with greater than 60 kilocalorie per mole energy, if you are going to take, then you will get disubstituted butane as the major product. That is 60 to 50 kilocalorie per mole. Sensitizer with 60 to 50 kilocalorie per mole triplet state energy, if you are going to take, then you will get vinyl cyclohexene as the major product. Okay, now let me explain. Already I told you in the previous lecture, your sensitizer should have equal or greater than this energy, I mean triplet state energy. So here triplet state energy is 58.3, so sensitizer with the energy 58.3 or greater than the 58.3 kilocalorie per mole. If your sensitizer is having, then you'll get this one as the major product. If sensitizer energy is less than 58.3, you'll get this product, but the percentage will decrease, proportion of this product will decrease. So slowly from 60 to 50, if sensitizer energy, triplet state energy, if decreases, then this product concentration decreases and the concentration of this product will increase, of course. So for cis form, triplet state energy is 53, approximately 53 kilocalorie per mole. So sensitizer with approximate energy of around 50 kilocalorie per mole will give this one as the major product, and greater than 60 or around 60, since it is 58.3, around 60 kilocalorie per mole, if your sensitizer is having as energy, then you'll get this these two as the major product. Okay, so among these two, transform will be the, since at room temperature this is more stable, so this will be the major product and this will be the minor product. Okay, so according to case 1, whenever you are going to use sensitizer with greater triplet state energy, that is greater than 60 kilocalorie per mole, you get these two as the major product. In case 2, you'll get substituted cyclohexene as the major product. Since to get substituted cyclohexene, we are going to use sensitizer with energy of around 50 to 60 kilocalorie per mole. Okay, so example for these two sensitizers. So here either you can take acetophenone. There are many sensitizers. I will attach the list of sensitizers. So here either you can take acetophenone or benzophenone, and for this you can take camphor quinone as the sensitizer, or pyrene you can take as a sensitizer. Okay, so for camphor quinone and pyrene, triplet state energy is around 50 kilocalorie per mole. So these two sensitizers will give this one as the major product, and acetophenone or benzophenone if you take, you'll get these two as the major product.